So it's my pleasure to introduce our next speaker, which is Michael Ficarra. Michael is a TC39 editor and long-term contributor to the JavaScript specification, and is someone who has had a really big impact on how JavaScript continues to evolve. He's done significant work as an editor to help mechanize the specification, which we've seen some of the impacts of that in ES Meta. He brings a mix of technical depth, language theory, and a healthy skepticism that makes him one of the most thoughtful voices in the room during our committee meetings. Today, he'll be talking to us about the tooling that supports the ECMAScript specification. Please help me welcome Michael.
All right. Yeah, that's on. Thank you. Yeah, Michael, I work at F5. I've been a delegate to TC39, the committee that standardizes JavaScript for over 10 years now, and editor for over 5. And I want to tell you about the tooling that we use to build the JavaScript specification. And to do that, I need to go through a little bit of history, so bear with me. I think it'll put everything in context. So, as many of you know, JavaScript was originally developed at Netscape for the web, but now it's all over the place. It's still used in modern web browsers, of course, but there's also standalone runtimes, which have become hugely popular. And there's also more niche use cases, like it's embedded in HTTP servers like Nginx. It's in operating system shells in GNOME shell, used in microcontrollers. It's in satellites, surprisingly. It's all over the place. It's like a cockroach. Andreas. Because we have this hugely diverse set of stakeholders, it's very important to standardize the language. It's being standardized for a long time now, since late 90s, in ECMA. And ECMA is this international standards body that is composed of experts and practitioners and implementers from industry and from academia, from government, from research institutions, all representing their interests. And these are representing interests from all over the world. Our specification is right here. It's called ECMA 262. ECMA just numbers all of the specifications. So we happen to be the 262nd one. So if you want to look at it, you can go there. And this is what it looks like. So we author the spec in English prose. The prose is partitioned into what we call abstract operations. They are a function-like specification mechanism. Though it is English, it is using highly regular and intentional phrasing. It's effectively a pseudo-programming language because we're so restrictive with that. But with the escape hatch of always being able to use English in any way we want to be able to make it more accessible or express ourselves differently. So we think that this is actually an appropriate trade-off for our readers. On the rigor spectrum, it's somewhere in the middle, right? We do have large sections where we very clearly define all of the specific phrasing we use, all of the words and what they mean, all the way down to what we expect to be common knowledge. And we have to remember that we're considering a variety of readers with very diverse backgrounds. So implementers are only just one of our reader. We also have the JavaScript programmers themselves, who may be new to programming, or they may be veteran programmers. People that are educators within the community, people that are writing documentation and need to kind of understand it and communicate the behavior better. Academics, of course, who are building automated tools, who are consuming this. So we have to consider all of those when actually authoring this document. And again, we think that this is the right kind of abstraction for our specification. It has shown over time to be sufficient to meet our goal, which is to have multiple implementations that do not diverge. So between this document and the official conformance tests, we very rarely nowadays see new features being implemented in engines and having a divergence from that. So I think that it is a success in that goal. So this is what we used to do. In the old days, we used to have a single editor who would use Microsoft Word to author our spec document. As Andreas was saying earlier, the committee members would kind of just throw features poorly defined over the fence at him, and he would try to write up what he thought they meant, periodically send out the changes and ask for clarifications, and that was a very, very labor-intensive role. Surprisingly, we managed to release 6 spec documents over the course of, I don't know, 18 years, is that? Using that process, but that it really isn't sustainable. The spec is constantly increasing in size over that time, as well as the scope of the language, and the rate of additions is increasing. But that's all I'm going to tell you on the history. There's actually a lot more interesting history. If you want to go read about it, there's this really good paper at Hopple 4, the History of Programming Languages 4, by Alan Worsbrock and Brendan Ike. I highly recommend taking a read. But so since 2015, we have a new, more decentralized, intentionally decentralized process. And with that, we have editor groups. So the editorial work is split. The editor groups are elected yearly. Sometimes they stay the same. And since 2020, I've been part of the editor group. But the bigger, more important change in our process is that proposals now have champions assigned to them who shepherd proposals through this 6-stage process. And importantly, during stages 1 and 2, champions author their own spec text, which distributes the majority of the editorial work there in defining new features. Don't worry about it. I keep having to field that question. We can talk about it later. It's just a number between 2 and 3. Anyway, that will forever haunt us. So yeah, as we're also transitioning away from centralized editing role, we also needed to transition away from a Microsoft Word document that we email around to each other, because that won't really support our process. So these were kind of the available options to us. We could write up like a plain text document like IETF does with our RFCs. Obviously, the emailing around a Word document is insufficient. There's like desktop publishing software we could use, like Adobe InDesign, to like make an ebook and like have full control over very specific bits about the layout. We could use LaTeX, but user friendliness isn't really there, or like Adobe FrameMaker would be able to be a similar like WYSIWYM tool. But we think the clear winner in this space is web technologies. I want to explain why. So, I mean, I guess I'm a little biased, but anyway, so like web technologies are all like free and open, meaning that that there's already like tons of developer tooling and libraries from the community. We do participate in the web space, so like our proposal authors are probably already familiar with web technologies. Everybody already has a web browser installed, so they don't have any special software to go get and install, or and none of it's proprietary. The web technologies all use text formats, which is like important for us, for collaboration. We're going to be like using line-based version control systems and like Git, and that works well for managing all of this work being done simultaneously. The web is like a really powerful platform, especially modern day, right? It has a lot of advanced interactivity features. It has like end user extensibility with extensions, which people can and have, as we've seen, written to extend the functionality of the spec. And it's important for us to be able to like share deep links into specific terms and like abstract operations, because we integrate with other specifications. So they need some way of referring to bits and pieces of the spec, and not just the whole thing. So the web we found is the ideal technology for us for writing our specification. So since 2015, our specification is a web application. This is what it looks like, and we get all sorts of powerful interactive features. I'm going to show you some of them. So like really simply, you can hover over like any term that's defined in the spec. And as I said, we have tons and tons of defined terms. You'll see them in italics throughout the spec, and then we can find all of their references throughout the document, and similarly, all of the uses of them link back to that definition. This is obviously just a very simple thing, but this also works for clauses or RDF sections, abstract operations themselves, non-terminals with grammar, and tables. All of those use that same feature. We also have interactivity with an algorithm where you can click on the different aliases that are used in the algorithm to highlight them, and they'll highlight in different colors when you highlight multiple of them. This helps you track, understand the like lifetime of an alias through an algorithm, which is just a very common thing that we need, and custom functionality that we were able to develop because of the like open nature of the platform. We also a feature that was requested and implemented by browser implementers is this ability to toggle on and off these annotations, which can show where like arbitrary user code can happen. This allows you to make certain assumptions about your implementation where arbitrary user code cannot happen, and gives you points where it's useful to revalidate the assumptions that you've made. This can be very helpful for implementers who are performing optimizations.
Was that, sorry,
yeah, okay.
Is that hand inserted, or is it derived somehow?
Somewhat. There are like manual annotations for like leaf nodes where where arbitrary user code execution happens, which is like just a couple, and then there's like automatic propagation, and there's additionally a couple of annotations where they stop propagation because they know due to other reasons that user code wouldn't happen there. But yeah, it's a combination. I think again, still simple features. I'm just showing that we have a lot of this interactivity. This is like pinning. So for each section, we often have like when you're reading the spec, you have to jump around a lot between a couple of different sections. You can just like press P or press like the pin button to add it to your list of pins, and then jump around to it. And I wanted to include this one as like to try to like emphasize really what I mean by when I say powerful. Like we have with the web, we have like custom control over what gets copied to the clipboard. So for example, when some implementers are like writing their implementation, they like to like literally copy and paste steps out of the spec and into their code as comments so that they can follow it like line by line. We have a lot of different implementers, and some of them like to do it that way. So we can control what text is copied to the clipboard so that it's like better for the text-based medium. You can see that here we're using like superscripts and stuff, which is better for a web rendering, but not great for like your source code. So yeah, I wanted to show these kinds of things because it's an example of like if you can think it, you can usually do it on the web platform. That's why we really like our decision to use it for our specification. Okay, so now I want to show you like the tooling that actually produces that document. The top level like spec generation tool is called ECMarkup. It's open source. It's in our TC39 repository. It's in our TC39 group on GitHub. So our spec document is a section of it is shown here on the right. It is authored as an HTML document with some custom tags thrown in, these like EMU dash tags. So it uses a library called JSDOM to actually work with the document as if it's like a living, as if it's like an active web page. So we get all of those like high level transformation functionality from using them like that. So again, just like kind of dogfooding all of the web platform technologies. And the editor group maintains this tool for the most part. So it does things like it generates a table of contents for us. It does all that reference linking that I was talking about earlier. It enforces a lot of our editorial conventions. That's like phrasing consistency, formatting consistency, all of that kind of stuff that, as much as we can encode within markup. It makes sure that within algorithms, aliases are appropriately declared before they're used and that kind of stuff, and not declared more than once in a path that's reachable from the same path. It embeds assets into the document. I don't think I need to keep going further. It does all the numbering for steps. It does numbering for clauses and make sure that when you refer to them that the numbers are appropriate and everything. One thing I wanted to mention though is it does do a limited form of type checking. It's not anything like what we saw with Meta earlier, but it does just make sure that abstract operations are invoked with the right number of parameters. That when a constant value is returned, it matches with the type signature of the AO, that kind of stuff. But not across different calls to different abstract operations or tracking a type of an alias through an algorithm. We have to use meta for that. I wanted to say, I did mention briefly, it processes this type signature. So we do have another grammar for type signatures within markup that we use there. It also uses a tool called Markdown. This is a separate tool that does the processing of these parts, the algorithm steps. So that's kind of just like a markdown, DSL for just annotating the different parts of the algorithm. So enclosed by underscores you are aliases, and abstract operation names are in that Pascal case, and that kind of stuff. It just it does all of that annotation so that we can then style them appropriately. We also depend on another tool. Again, this is all maintained within the committee, called Gram Markdown. It might get confusing with the names, I know, but this has a similar responsibility as Markdown does for the algorithm steps, but instead for the grammar sections. It does it parses it and does all the annotation for the different components. So Jacques mentioned earlier that we do integrate with ESMeta now. So I don't have to tell you, but ESMeta automatically generates this mechanized specification, and then it does our type checking for us. So we integrate with it in CI, and it has exceptions. There are certain things, certain sections that it doesn't check, like the memory model section, like the atomic section, but that's okay. We still get a lot of value out of it. And for the areas where we have particular phrasing that it doesn't understand, or where we have just recently introduced changes where it doesn't understand things, we have this exclusion file, so it can never really get in our way. It only ever is helpful. So we're very happy with how we've designed that integration with ESMeta. There we go. I also wanted to throw this interesting use out there. We use aspell for doing spell checking of the spec, just a simple enough thing. But I think the way we use it is a little bit interesting. We don't want to just use it with a standard dictionary, because we use a lot of terms of art, or we use technical terms, computer science terms that it might not be in standard dictionary, and we don't want to really have to maintain a big dictionary of all those things. So instead, what we do is that every time it runs on a pull request, it derives a dictionary from the target branch. It just looks at all of the terms that are already in use, and it even does things it splits up things that are in camel case and Pascal case into the components, and assumes that those are themselves words, or good enough to be words, and then it builds a dictionary based on that, and then it checks the pull request branch, the feature branch, using that, which allows us to just really detect when new misspellings and stuff are introduced. And I know misspellings aren't very interesting from a programming perspective, but from an editing perspective, it's a thing we deal with frequently enough that it's a problem we'd like to solve. Is it? Well, again, it goes through the whole document. It finds everything that already exists that wouldn't be in the dictionary, and it adds it. So yes, these are the like what we call novel words, the exceptional things in here. It's weird. Anyway, yeah, I think the casing probably doesn't matter. I don't know. You can try it out, but like again, it's not just solving these like programming language related technical problems. We also solve all these just like generally editing a document at this rapid pace with lots of different contributions from different people who all make mistakes, and we're trying to make it avoid those. So I've been preaching this whole time about like how we really love using web technologies. There is a downside though. ECMA does require us to release a yearly PDF. This is part of their standardization process. So like they for like many reasons they need a PDF. They will actually print up books with the specification, so it's important for them. So there are ways to generate PDFs from web documents, but they have some downsides, right? Like there are some things you would expect of a printed like book or printed PDF that you wouldn't expect of a document on the web. So like the table of contents should have page numbers, whereas that's not like a concept on the web. And on tables, you would expect them to like split across pages, and then when they do split across pages, that the header and the caption would be like copied on the next page. Again, these are just like things that they don't happen automatically when just printing a document, and they're kind of expected as like a minimum quality level. So how do we do that? Oh yeah, and like there's a lot of these things. I just mentioned like two of them, but like we created a list, and there's a lot of things to consider. The good news is that there is a standard, W3C standard for paged media, which allows us to like actually write down all of these things that we want in a PDF document. And with that, we should be able to generate like really high quality PDFs. The bad news is that no browser implements this standard, which makes it arguably not a standard, but that is a thing that W3C does that's a little bit different than what we do, is they publish things and call it a standard even if nobody has implemented it. But there is an implementation which is not on the web, and I think maybe the only no, I guess there's two possibly. I don't know, but there is no web implementation. But there's this proprietary tool called Prints. So even though we don't have a browser that supports that printing standard, we do only generate this PDF one time a year, and it's only us who generates it. So we can just use this commercial implementation. So it would be really nice to get to a point where anybody could generate the print version of our document at any time, but that's kind of now just like one-off thing that we have to do privately. So anyway, yeah, that's like the tooling that we use that's involved in our spec document. And I wanted to go over some opportunities that I see. Like, I've talked about like what we do now, and I think that that's actually really a small amount of stuff compared to like all the stuff we could be doing in the future. So I just wanted to give some ideas, just like maybe like prompt something new that you might want to contribute or look into. So I did talk briefly about like how champions, move a proposal through the proposal process, and they write their own spec text. This is what that ends up looking like. What they do is they will make a new document. It will still be an HTML document that runs through ECMARkup, but they will just copy and paste like relevant sections to their proposal into this proposal document, and then add these like insert and delete tags where they want to make changes and describe their change in that way. So it's just like a partial look at the document. It's kind of scattered, and you have to, if you want to just look at like what it would look like integrated, you have to kind of squint and keep two documents open at the same time. It's not great. There's also like, we lose a lot of the tooling support because it's just this like partial document. And then, where we do have like links to things that are not overridden in here, they link to like the full document, which then you could forget that you're actually looking at the old version and not the new version when you're looking at it. It's just not a great process. So something I really hope somebody looks into and just does for me one day is like creating an actual like semantic diff calculus for the proposal for the spec, so that people can proposal authors can write their proposal in terms of these like semantic changes, and not like line-based changes or like text-based changes. So I think that would be like an interesting area of research. It would help them keep their proposal document up to date as the spec is changing as well, much more so than line-based diffs. There is kind of a tool like this from a Mozilla engineer who generates what looks like that proposal document that we were talking about, but based on a pull request. So it takes any pull request, which again is just sending a line-based diff, and then generates that proposal document. But it has similar issues, right? You're still going to be having more difficulty keeping it up to date with this constantly evolving spec. Like maintaining that pull request is more work than maintaining this like diff description. But this does have many of the same benefits I'm looking for. So something along those lines would be really cool, I think. Mikhail is doing is starting to look into doing this like collaborative language design workbench idea. Please talk to him more about it now, since you're here and he's here. But I think something in this space that there's like a lot of opportunity. So it's not like what you would typically think of as a like language workbench. It's more of also like incorporating all of the social aspects and the process aspects of language design within like a large committee into the tooling itself, which I think there's like a lot of opportunities to help us out there. And also looking into like how to evaluate the effects of proposals. So this is an example of a tool that was created by one of the proposal authors for the record and tuple proposal. So this tool allows you to look at a bunch of examples of points where we'd have to make a design decision about how that feature should work, and then choose what you think the result should be. And then on the right, it'll tell you like why that's like going to be a problem. And in this case, for like record and tuple in particular, it's always going to tell you that there's some problem. There's just really like there's a lot of questions that have no good solution. But it's easy to forget, as you are going through all these different decision points, why that other one wasn't a bad idea, why there just isn't a route forward. And this helps you just keep it all right in your face. And anyway, so that there was actually a paper published about this. So you can publish about this stuff. Again, I would love to see this research continue. So this paper was defining a framework for creating tools like we just saw. And actually, it at as a lead this year won Distinguished Paper and Distinguished Artifact Awards. So congratulations, Mikhail, for that. I would also like to see, so that's like more of on the design side. I would like to see tooling, but I would like to see more tooling embedded, or like more interactivity embedded in the spec document itself. So a committee member, Nicolo, made this tool that will show like internal spec states for a module graph that you describe in those input boxes right there. And it renders it for you, so you're making sure you're describing the right thing. And this is good for like implementers who want to confirm that, like, if they're following the implementation, like that they've understood what they've read from the spec, right? It's a very complex component. So if they can actually interact with something like this in the spec document itself and see what like internal state would be given some example state passed in to like the AOs, I think that would be like a helpful way to understand things, right? Right now, it's just a like static text document for the most part, and that can't possibly be the best way to get to communicate the things we're trying to communicate. Maybe this is more up your alley. We have like editorial conventions document, which is like just a wiki page. That's basically just like notes to ourselves to try to remember to like uphold these principles and follow these like phrasing standards and stuff. I think there's probably work here to be done about like more formally encoding this and then making tooling that can like automatically enforce it and maybe like generate good examples and bad examples or something like that. I don't know. I would love to see that more formalized and explicit. And if this kind of stuff just generally interests you, but like maybe none of those particular proposals do, you can join our group, the TG5 within TC39. Anybody should be able to attend under invite. So let me or Michael know, or Julia for the next couple of days maybe. And you can come and we don't talk about just JavaScript. It's more about all research questions related to languages that could then influence how JavaScript is designed and advances. So if there are any related languages that have like similar aspects, we're happy to discuss those research questions as well. And that's it. I'd love to take questions.
Thank you very much, Michael. Don't quite have a visual in the room yet, but if anyone had a question, please feel free to signal Mikhail to get the mic.
Yeah, thanks for the talk. It's great to see how much things have advanced and like left this community. So I guess I have a couple of comments or both comments and questions. So one is about PDF. So of course we also have that discussion, and we actually have a lot of people who use the PDF, right?
Yeah, we actually have a surprising number of people who use the PDF, like who are implementers as well. Yeah,
right. Because usually it's actually more readable and more well typeset than anything on the web, especially when you have math. Math on the web is a disaster, right?
We have a couple of implementers who like to print out just the relevant couple pages and keep it right next to them, and that's their process. So
right. So that's one reason why. Another thing I wanted to ask is, so one complaint we sometimes get is about accessibility. Of course, with math in it, it gets even worse, that problem. Like people who are blind and can't like just read it off the screen. So they depend on the screen reader. With math, you don't have much of that, especially since MathML is not a thing, or did not used to be a thing. But also, I guess, like if something like the ECMAScript spec moves more towards like stylized symbolic meta operations, symbols like colon and bang and question mark things, is that something that comes up for you as well?
We do think about accessibility to some degree. Like we discuss it fairly regularly within the editor call. But for things like, we've tried to make sure that like we've chosen a font that's like highly readable, that we've chosen colors that are high contrast. What else was it? We use like with /0s to make sure that nobody with like low vision is having trouble. So like, but not to the degree, like we still have diagrams that are not that don't have like alt text that would fully describe them. Yeah, I'm sure that there's things we could do to improve accessibility, but we have done a lot. I would love for somebody who's like more of an expert in accessibility to help us get any further, because I think we've pretty much exhausted like what we can do as non-accessibility experts to make it any better.
Yeah. Okay. And then I have a maybe slightly inflammatory question. Okay.
I love it.
So isn't the fact that even implementers need all this interactive tooling to understand what's even going on a sign that maybe something is not so great about the whole design of either the language or the spec? I don't know.
I don't think I disagree with you. The module system design is very complex, and that it is at this point it's kind of just legacy we live with. I know for you it's more of like this is a new thing, but the the module system is over 10 years old, and we made some decisions early on that are kind of haunting us as we're trying to as we're finding new problems that we're trying to apply to it, right? Like we have like top level weights, and like how does that integrate well with the modules that load lazily? I agree with you that it's very complex. So yes, it does just show us how complex it is.
Okay.
Yeah.
Cool. Thanks.
Just to chime in here, I think that this is an interesting artifact of modular language design evolution. Something similar. Well, it was called just-in-time specification by during the Kotlin talk, but it's quite interesting that we can't predict all of possible requirements that the language will have before those requirements arise. So, for example, with the module system, when we try to find the best possible solution given what we know the problem is going to be, and then later on, 10 years later, we suddenly have a different set of requirements that we need to address, or requirements that we had rejected earlier turn out to be more important than we thought. I think that's interesting. It results in interesting artifacts that can be maybe arguably a worse language design, but then how do you actually have that foresight of what will be important in a highly dynamic space like web programming in 10, 20 years?
Yeah. An earlier speaker brought up how like the iterative process is really good in a lot of ways, but it can also work you into a place that is worse than if you would have designed everything up front. But you probably would never get to that point because the language would have been dead by then.
Yeah, it's an interesting tension. And I think this is something that we have heard. I think recently in PLDI, there was a conversation about layering different kinds of paradigms. Like that's something that JavaScript has had some struggles with, and how you might do that in a more rigorous way. So I think there's definitely a lot of interesting programming language design work that could be done here.
Yeah.
Do we have any other questions? All right.
Okay.
In the interest, thank you very much, Michael.